So if the compound that consists of carbon and hydrogen, they are said to be hydrocarbons. This open chain hydrocarbon, which are nothing but aliphatic hydrocarbons, and there are of two types. They are saturated hydrocarbon and unsaturated hydrocarbon. So in organic chemistry, before writing any reaction directly, first you write the general reaction so that by using that general reaction you can easily write the example. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, let us begin with a new unit called hydrocarbon. So before going to discuss with this unit, let's see the weightage of this unit. So from this unit, we can expect totally 10 marks. There will be a 1 mark question and there will be a 2 mark question and there will be a 5 mark question. And the question number goes like this. The question number 10 from the part A, the question number 16 and 17 from the part B, and the question number 37 from the part D will come from this unit, and totally we can expect the 10 out of 10 from this unit. And this is one of the simplest unit where you can easily got 10 out of 10. So let's see what we are going to discuss in this session. In this session, we are going to deal with the introductory part of this unit. That is, we are going to discuss with the hydrocarbons and the classification of hydrocarbons and the methods of preparations of alkanes. We are going to discuss. Okay, let's see what are hydrocarbons first. We are already studied that hydrocarbons are nothing but an organic compound which consists of carbon and hydrogen. The best example is I can give methane. So in the methane, we know that there is only one carbon atom will be there attached to the 4 hydrogen atom. Is it right? So if the compound that consists of carbon and hydrogen, they are said to be hydrocarbons. And remember, these hydrocarbons are broadly classified into 3 classes. They are known as aliphatic and alicyclic and aromatic. Aliphatic in the sense, the carbon and hydrogen atom, they are aligned in a straight chain. Whereas alicyclic, the carbon atom as well as with the hydrogen atom, they are present in a cyclic manner. The best example I can give you is CH2, CH2, CH2 and CH2. So this is cyclobutane. Cyclobutane. This is a structure of cyclobutane and this is a methane. Where you can clearly understand that, you can write one more example to understand aliphatic hydrocarbon. I can write CH3, CH2, CH3. This is propane. Is it right? So all carbon atom, they are arranged in a straight chain. If it is present in a cyclic structure, then we say it is aliphatic hydrocarbon. And we have one more hydrocarbon. It always begins with a benzene ring. It always starts with a benzene ring. The best example is toluene. Example is toluene. Okay. So this is how we can easily understand the differences between aliphatic, alicyclic and aromatic hydrocarbon. Always remember, aliphatic hydrocarbons are present in a straight chain. Whereas alicyclic, the name itself shows that it is in a cyclic manner. It always present in a cyclic manner. Whereas in aromatic hydrocarbons, it will always start with a benzene ring. This is how we can represent the 3 classes of the hydrocarbon. Now let us see what are the classification of hydrocarbon. We can broadly classify the hydrocarbons into two types, that is open chain hydrocarbon or closed chain hydrocarbon. Open chain or closed chain. What is that open chain? This open chain hydrocarbon, which are nothing but aliphatic hydrocarbons, and there are of two types. They are saturated hydrocarbon and unsaturated hydrocarbon. If I say it is saturated hydrocarbon, remember between the two carbon atom there will be a single bond. And the best example for the saturated hydrocarbon is alkanes. And the general formula for representing the alkane is CnH2n plus 2. Similarly, for the unsaturated hydrocarbon, we say it is alkene and alkyne, which means to say that between the two carbon atom there will be a double bond, and between the three carbon atom, if it is a triple bond, we say it is alkyne. If it is a double bond, we say it is alkene. Okay, and general formula for the alkene is CnH2n. For alkyne is CnH2n minus 2. Okay, and this is how we can represent the differences between saturated and unsaturated hydrocarbon. And next comes to the closed chain, which are nothing but a acyclic hydrocarbon. This is of two types, that is alicyclic hydrocarbon and aromatic hydrocarbon. Always in the aromatic hydrocarbon, we always used to represent with a benzene ring. Whereas in the alicyclic, we used to represent in the cyclic manner. This is cyclo. There are three carbon atom will be there. Cyclopropane. This is how we can easily classify the hydrocarbons into following type, that is the open chain and closed chain. If it is an open chain, again there are of two types, saturated and unsaturated. If it is a closed chain, there are again of two types, that is alicyclic and aromatic. So hope you are understood with this classification along with the example. Now let's see with the what is a saturated and unsaturated hydrocarbon. Already I have explained that the saturated hydrocarbons are those in which between the two carbon atom there will be a single bond. And the general formula for writing the alkane is CnH2n plus 2, and the members are named as methane, propane, ethane, butane, pentane, hexane, like that. Okay. So between the two carbon atom there will be a single bond. When it comes to the unsaturated hydrocarbon, already I explained that there will be a formation of two double bond, or it may be triple bond also. If it is in a two double bond, then we say it is alkene. If it is a triple bond, then we say it is alkynes. So it is alkene and alkyne. So between the two carbon atom, there will be a double bond, and between the two carbon atom, there will be a three double bonds will be there. So this will be three double bond. Example for the alkene and alkynes are ethene, propene, butene, etc. For alkane is ethine, propine, butane, hexane, heptane, like that we can name it. Next is, after knowing this classification of the hydrocarbon, we need to understand what are alkane in depth, alkene and alkynes. Okay. First I'll go for the alkanes. In that, how to represent the members of the alkane, then what is the preparations of alkanes, what are the physical properties of alkane, and what are the chemical properties of the alkane, let us understand. Okay. First I'll go for the alkane. Already we have understood that alkanes are the saturated hydrocarbon, and between the two carbon atom there will be a single bond, and this alkanes are represented by the general formula called as CnH2n plus 2. And these alkanes are generally known as paraffins. Para means in the Latin word little, and affine means affinity. Paraffin means they have a less affinity towards the solvent. Okay. Here By taking this formula, that is CnH2n plus 2, I am going to introduce the members of the alkane. How to do this? First, I will take the formula, that is CnH2n plus 2. If n is equal to 1, what will happen to the formula? C1H2 into 1 plus 2, it will become CH4. Is it right? So, if n is equal to 1, number of carbon atom is 1, then we use the root word as meth. And it is named as alkane, because for the alkane, the suffix should be end with ane. So, it is methane. Okay? And it is a molecular formula is also methane, whereas our IUPAC name is also methane. Then comes to the, if n is equal to 2, then there are 2 carbon atoms will be there. If you substitute to the formula, you will get there are 2 carbon atoms, there are 6 hydrogen atom will be there. So it is ethane. Why? Because the root word is eth. And the last word should be end with ane because it is an alkane. So it is ethane. Similarly, if n is equal to 3, it will become propane. Formula is CH3, CH2, CH3. Next, if n is equal to 4, then we say it is butane and the formula is CH3, CH2, CH2, CH3. Similarly, if n is equal to 5, then we say it is pentane and the formula is CH3, CH2, 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 CH3. Then if n is equal to 6, then we say it is hexane. The formula goes like this, CH3, CH2, 4 times CH3. If n is equal to 7, then we say it is heptide. So the formula will be CH3, CH2, 5 times CH3. If n is equal to 8, then we say it is octane, CH3, CH2, 6 times and CH3. If n is equal to 9, then we say it is nonane and the members will be goes like this, CH3, CH2 7 times CH3. If n is equal to 10, then we say it is decane and the members will be goes like this, CH3, CH2 8 times and CH3. This is how we can easily write the members of the alkane by using this formula, where you can put the values of the n from 1 to 10 and you can write the members by knowing the root word. So, hope you know this root word that you have already studied in your 10th standard. Okay. Next, I'll go for the preparations of alkane. It is very important. Till now, what we have studied that we have already learned in your 10th standard. But the next portion of the alkane is we need to know that how we can prepare the alkane, what are the physical property, what are the chemical property. That is very important and it comes under your first PUC level. Okay. So, when it comes to the preparation, I'll go with the first method by using Wood's reaction. So, again this question will be very important for 2 marks. So, we are preparing the alkane by using alkyl halide. What does mean by alkyl halide? Alkyl halide in this sense, we represent with a general formula called as Rx. And this R is nothing but an alkyl group. Okay. And this may be CH3 or C2H5 or C3H6, like that it may be. Alkyl group it is. Whereas X is nothing but a halogen. It is nothing but a halogen. It may be chloro, bromo, iodo and fluoro. So, what is the general representation of the alkyl halide? Rx. So, by using this alkyl halide, how we can easily prepare the alkane? Let us understand now. Alkyl halide reacts with metallic sodium in presence of dry ether to form a alkane. So, here I have considered the general reaction. This is my general reaction. So, in organic chemistry, before writing any reaction directly, first you write the general reaction so that by using that general reaction, you can easily write the example. That is one of the tricks I like to give for you. So, when you write the general reaction, that is Rx, which is allowed to react with the sodium metal, what will happen? In presence of dry ether, here I have used the 2 moles of alkyl halide. So this R and R will get substituted and this sodium combines with the halogen and forms a sodium halogen. And this R and R, which are nothing but alkanes. Okay. Now, I'll substitute the values, or I can substitute the R with the CH3. So, my halogen is my Br. So, the name of this compound is bromomethane, which is allowed to react with the sodium metal. In presence of dry ether, it forms what? Ethane will be formed along with the release of sodium bromide. Similarly, you can take bromoethane, which is allowed to react with the sodium metal. In presence of dry ether, it forms a N-butane. Why it is N-butane? Because all the carbon atoms, they arrange in a straight chain. Hence, it is named as N-butane. Okay. Now, I can write one more examples for you. That is CH3, CH2, 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 CH3. Okay. I said I am using 2 moles of alkyl halide. So, this is my Br and I'll write one more molecule CH3, CH2, 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 CH3, Br. It allowed to react with sodium metal in presence of what? Dry ether. In presence of what? Dry ether. It forms what? This Br and Br goes with the sodium metal and forms what? It forms CH3, CH2 6 times and CH3. So, this is my compound and it is named as pentane. It is named as pentane. Okay. This is how, along with the release of 2NaBr. This is how we can write the example for the Woods reaction where my alkyl halide react with the sodium metal in presence of dry ether, it forms a hydrocarbon. It gives a alkane. Okay. Next is by reduction of alkyl halide. So now we have understood that how this alkyl halide which is going to give a alkane. By reducing this alkyl halide, how we can prepare the alkane? Let's see now. First, we will take the alkyl halide upon reduction with zinc and with the dilute HCl which give rise to the alkanes. Now, I have taken out the general reaction. So, what is the general representation for the alkyl halide? Rx. In presence of the zinc metal supported with the dilute HCl, what will happen? You are going to add one of the H plus ions. So, this H will goes and attacks to the R and forming a R and H, and another hydrogen will be combined with the halogen atom. The best example is chloroethane, which is undergo reduction in presence of zinc metal supported with the dilute HCl. So, one of the hydrogen will attacks here and forms a ethane, and remaining H combines with the Cl and forms a HCl. One more example I can write is CH3Cl, okay, which is allowed to react with zinc metal in presence of dilute HCl. What will happen? You are going to add the H plus ion and forms a CH3H, and remaining one H combines with the Cl. And you can write the CH3H as CH4. So, this is a methane, where my alkyl halide undergo reduction to form a alkane. Okay. So, hope you all understood with this the reduction of alkyl halide. Next one is by unsaturated hydrocarbon. What does it mean? Already we have understood that what is an unsaturated hydrocarbon. Is it right? What are the unsaturated hydrocarbon? Which may be an alkene or alkyne. By using an alkene and alkyne, how do we prepare the alkane? Let's see now. So, it is very simple here. The hydrogen gas which is added to the alkene or alkyne to obtain the alkane, but here we use some of the catalysts known as a nickel catalyst we use for this, or you can use palladium as well as with a platinum catalyst. Suppose if you are using the platinum and a palladium catalyst, we can use it at room temperature. Suppose if you are using the nickel catalyst, we need to raise the temperature to the 200 degree. Okay. So first I will write the general reaction for the alkene. R is my alkyl group, and we know that if I am writing the alkene, there must be a double bond between the two carbon atom. So it is RCH double bond CH2 in presence of nickel as a catalyst, and I am raising the temperature to the 250 degree, so that if you are adding the hydrogen, it goes and attacks to this carbon atom and break this bond and forms the alkane. Okay. Here also I am taking the one more example for the alkene, that is CH3 CH double bond CH2. If you are adding with the hydrogen in presence of a nickel as a catalyst, it goes and attacks to the first and second carbon atom and forms a propane. Similarly, you can write it for the alkyne. I have written for the propine CH3C triple bond CH, and when you are adding the hydrogen, you must careful here. We know that there is a triple bond between the two carbon atoms. So you must write two hydrogen atom you are adding, so that it will become propane. This is how by using alkene and alkyne also we can prepare the we can easily prepare the alkene. By using unsaturated hydrocarbon also, we can easily prepare the alkane, and it is also one of the simplest method for the preparation of alkane. Next one is from monocarboxylic acids. So mono means what? Single. So we know that for the carboxylic acid, we usually represent the general formula as RCOOH, where COOH is my carboxylic acid group. Is it right? How do we prepare it? Let's see now. So the first one is the decarboxylation of fatty acid. The sodium salts of aliphatic monocarboxylic acid upon heating with the soda lime, which give rise to the alkanes. What is my sodium salts of carboxylic acid? We know that we represent the carboxylic acid as RCOOH. If I replace the H with the Na, then we say it is sodium salts of carboxylic acid. If I replace with the potassium, we can say it is potassium salts of carboxylic acid. So it is very simple to remember that what is the sodium salts of carboxylic acid just by replacing the H with the sodium or H with the potassium. Okay, when you take the potassium and allow to heat it with the soda lime. What is our soda lime? We know that soda lime is a mixture of sodium hydroxide and calcium oxide. This mixture, it is said to be soda lime. Okay, soda lime. When you are taking the sodium salts of carboxylic acid and heated in presence of soda lime, what will happen? Again here, the R combines with one more H and forming a RH, that is nothing but a hydrocarbon, whereas Na, there are two Na will be there, so Na2, and you can see that CO3 will be there. Why is it so? You can count here, one carbon with a 3 oxygen. So it is Na2CO3. You can look at with the example now, CH3COONA, which is allowed to react with the soda lime. What will happen again? The CH3 combines with this hydrogen and forming methane. It is an alkane. Whereas the sodium, there are two sodium will be there, Na2 and CO3. There are 3 oxygen atom will be there. This is how we can easily understand that how we can prepare an alkane by using the sodium salts of carboxylic acid. So hope you understood with this method. You can write one more example for this. C2H5 COONA plus NaOH and give rise to CaO, that is C2H6 plus Na2CO3. This is ethane. This is ethane. Okay. Next, by coal-based electrolytic method. It is very, very important for the examination point of view, and they'll ask what is coal-based electrolytic method. Here, we can prepare an alkane by using electrical field. How does? Let's see now. When an aqueous solution of sodium or the potassium salts of aliphatic carboxylic acids are electrolyzed, alkenes are formed at the anode. Why is it so? We know that if you take the sodium salts, first I'll write the general reaction for the carboxylic acid, that is RCOOH. During the electrolysis, what it forms? It forms an anion along with the cation. Is it right? This is my anion, this is my cation. Like that, if I replace the H with the sodium, it will become RCOO minus plus Na plus. Sodium is my cation and RCOO minus is my anion. Here, that is why I have written this example where I am replacing the H with the potassium. This is the potassium salts of carboxylic acid. CH3COOK, which is upon electrolysis, which give rise to an anion as well as with one cation. So, when you take the aqueous solution of the sodium salts of carboxylic acid or the potassium salts of carboxylic acid, and if you apply the electrical field, what will happen? The ions will be dissolved in a solution and forms the cations and anions, and this cations and anions goes to the respective electrode. Is it right? At anode, what will happen? We know that at anode, CH3COO minus, which give rise to the CH3COO radical by losing one electron. This again the CH3COO radical, which give rise to the methane radical and CO2. This methane radical which reacts with another methane radical and give rise to the ethane, which give rise to what? Ethane. Remember, in the first step what will happen? This CH3COO minus, which forms a CH3COO minus radical. This CH3COO radical again forms a CH3 radical and CO2. This CH3 radical reacts with another CH3 radical and forms a ethane, and it is an alkane. Similarly, at the cathode, we know that H plus ions will be there, and we know that H plus ions which is also formed due to the water molecule because we have done the aqueous solution. So, H plus and OH minus, and we know that this H plus ions which loses one more electron and forms a hydrogen radical. This hydrogen radical combines with another hydrogen radical and forms a hydrogen molecule. So, the general electronic reductions can be represented like this. RCOOK plus 2 water molecule give rise to R and 2 CO2 and H2 and 2 KOH. How does this K comes here? This K is mainly due to the presence of the potassium salts which is present in the potassium salts of carboxylic acid, which is combined with the OH of the water molecule and forming KOH. This is how when you apply the electrical field, especially at the anode, the alkanes will be formed. So, by the next session, I am going to do with the physical properties of the alkanes as well as with the chemical properties of the alkane. By this, I like to say that what are all the things which I covered in this session, especially focused on with the preparation methods of the alkane. Wherever you are not understanding, please pause the video and try to note that important point in your preparations of alkane, and we'll meet you in the next session. Till that, take care and be safe. Thank you.